Scale Up Nation, one of my favorite things about the Rising Tide Mastermind is a session that we do called a full cup. And a full cup is where we bring a tip or a trick to each other that can really help improve our regular day-to-day. And a few months back, Eric Russo, member of the Mastermind and has been on the podcast several times, he brought to us the Rocket Book. Folks, the Rocket Book is amazing. The Rocket Book allows you to take notes just like you would on any other notebook, but it has a scanning feature that turns what you write into searchable text. It makes your notes able for you to find. This was a game changer for me, and I know it can be a game changer for you. We have an affiliate deal worked out with the Rocketbook, folks, so you can go to scalinguph2o.com/Rocketbook, and you can receive 15% off your first order of $20 or more. Welcome to the Scaling Up H2O podcast, the podcast where we scale up on knowledge so we don't scale up our systems. I am Trace Blackmore, the host of the Scaling Up H2O podcast, and I got so many calls last week. Trace, where was the rest of the episode? I kept you in suspense. Don't worry, we're going to have Tom Tinney for part 2 and the conclusion of our interview. I know you can't wait for us to get to that, but I do have a few announcements before we get to the conclusion of our interview with Tom Tinney. And so many people are keeping up to date with what they need to go to when it comes to the world of water by going to our events page. And I know a lot of people listen to this podcast to stay up to date on information about what's going on. But let me tell you, I only talk about a fraction of the things that actually are going on. So if you didn't hear it, it doesn't mean it doesn't happen. It means I just don't have time to talk about it. So go to scalinguph2o.com, go over to our events page, and we're going to have everything that I did not talk about. We're even going to have things that I did talk about. And my team made it so easy. You just click on them. It opens up a new site so you can read all about them, and you can even mark your calendar. So cool what they put together, all to make it easy for you to be in the know when it comes to industrial water treatment. Well, the one thing I hope you have on your calendar is one of my favorite things, and of course, that is the hang. The hang is when we get together with you, the Scaling Up Nation, and we do a very quick 1-hour Zoom video call, and we get to meet each other. You get to meet each other. You might even get to work out a couple of issues. And so many times I have heard where people joined the hang, they didn't know anybody, they met a couple of people, but there was this one person that they got their contact information. And then months later, they had an issue and they remembered that they had that contact information and they called the person, and that person was able to help them with their issue. And that's what collaboration is all about. We don't have to experience something in order to learn from it. We can learn from somebody else's experience, and we can use that experience to really make sure that we are doing the best job possible for our customers. So to learn more about the hang, where all things like that happen, go to scalinguph2o.com/hang, and we're going to have all the information that you need. You can mark your calendars and be sure to be on that call at 6 p.m. Eastern Time. I'll get you off in exactly 1 hour. And I can't wait to see you there. Another conference you might want to be familiar with is the New England Water Environment Association. They're having their conference January 26th through 29th in Boston, Massachusetts. So we're going to have all of that information on our events page. Or maybe you're in San Diego, California, January 27th through 29th. Well, that's the Clean Tech Forum North America Conference. And then if you're in Austin, Texas, January 27th through 29th, you might want to check out the Waterford, Texas 2025 conference. Of course, we're going to have those and more listed on our events page. All you have to do is go to scalinguph2o.com, go over to our events page, and we're going to have all that listed for you. Well, Nation, I know you are excited. You enjoyed last week's interview. You want to hear the conclusion. I'm not going to let you wait any longer. Here is the conclusion of my interview with Tom Tinney. So I'm wondering if my flow switch is working properly. How can I use my multimeter for that?
So I always recommended the mighty paperclip to check that. But
it's a multimeter show, though.
It's a multimeter show, so we're going to give it the benefit of the doubt. So with the multimeter, what I can actually do is set it for resistance again, or even use the diode function, either one of those. I'll take the wires from the flow switch out of the controller. There'll be two of them. I put one lead on each wire, and I go ahead and turn the flow on for the system. And I should either get that diode beep or I should read a short. So my ohm meter should be reading maximum ohms, which is typically indicated by a 1 with like nothing after it, or a 1M or a 2M, which indicates mega ohms of resistance, total resistance. And then it should shoot down to either 1 or 2 ohms or 0 if the flow switch activates. When the flow switch pops up, I don't get a short or a beep on my diode, that flow switch read switch inside it is bad and you probably need to change it. So, and that's also, again, when people extend flow switches, that's the one that they mess up on as well. And we talk about this wiring too. All of these signal wires from these low voltage sensors should never be run in the same conduit with like 120 volt AC current. The AC current is a varying current. It goes up and down, and that can actually look like a water meter count. So if I ran my water meter low voltage wire through the same conduit as my AC, I'm going to get a fake signal. And all of a sudden I'm accumulating a water meter value, and I know the water meter is not activated right now because my tower is not filling. So why am I getting it? It's because they ran too close together. So
now, Tom, I need your help with this, and the Scaling Up Nation needs your help with this, because I can't tell you how many conversations I have had with electricians. I told them exactly what you just said and why we need separate conduit, and it doesn't happen that way very often. It's one conduit because that's what's run. How do we have a better conversation around that?
I'm more than happy to get on the phone and just chew them out. First of all, it's against code to run low voltage, and typically against local code to run low voltage and high voltage through the same conduit. So that's a bad idea. Even worse idea, because they swear the conduit's grounded, is they take the water meter wire and they tie wrap it to the conduit for the entire length. It's outside the conduit, it's not touching. But the conduit isn't necessarily truly a ground. It's grounded, we hope. But all those little conduit connections where they screw the boxes together, those aren't necessarily conductive all the time. Plus they corrode over time. And all of a sudden it's acting as a transformer as well. So separated by 12 inches and crossing each other at a 90-degree angle is the correct way to run low voltage with high voltage. Now, once you get up to the controller, it's like, hey, my udders are hanging right next to the wire going in. That's a little different than a 30-foot run side by side the entire length where you've just created a huge transformer. So equidistance or right on top of each other for that long, you've created a transformer, and that signal is going to jump.
Since we're talking about water meters, how would we troubleshoot one of those?
Well, so this is kind of, again, I'm going to diverge to the mighty paperclip. So you take a paperclip, you bend it into a U shape. The two wires that come in from your water meter, you go to those two terminals, wherever they land, and you basically take your paperclip and you touch it, both terminals. So you're shorting the terminals together, and you touch it for at least a second, and you take it off, and you touch it again, and you take it off. And you should be accumulating on a contacting head water meter a signal. You should see you go up by 100, 200, 300. You're simulating that signal. If that's not occurring, then remove the wires from the water meter, remove them from the controller, and do that same exact test again on those same terminals. And if it starts accumulating, what's that tell us? What that tells us is the wire run out to the water meter is actually shorted together, and it's running a signal that's completed all the time. So when I was touching it with my paperclip, I wasn't doing anything other than completing an already complete signal. When I take it off, the signal's still complete. I didn't have a variance. I didn't have an on and an off, which is what a water meter is looking for. So then if that's the case, obviously you can actually take the wires and check them on the water meter, or take out your multimeter, again, set it for diode or resistance, and touch both those wires going to the water meter. it should read an open or maximum resistance when it's just sitting there. And when the water flows through it and it clicks that one time for 100 gallons, you should see your multimeter screen change very quickly and then go right back to being wide open. If you're reading a short or you're reading 100 ohms or 50 ohms, I'm sorry, they've stripped the wire and it's touching in that conduit run somewhere, and they're going to have to pull some new wire. It is what it is.
Tom, how long can a run be on a water meter?
1,000 feet. So the cool part about a signal is if I'm looking for signal variation, I'm trying to capture a very finite signal. I want the minimum run because I don't want it. It's going to lose amplitude over a long distance. So I really don't want it. But with a water meter, what we're doing is it's a conditional signal. It's either powered on and passing a signal or powered off with it open. So I'm just looking for a state change, and that state change can have that longer variance. Conductivity sensor with twisted pair wire can run maybe 200 feet. Sometimes any sort of preamplified pH sensor or ORP sensor can run 1,000 feet. Any standard pH sensor without amplification is typically 20 feet. And 4 to 20 milliamp signals, which are like your PTSA sensors, your drum levels, and that sort of stuff, 1,000 feet. I mean, it doesn't bother those links for that.
I don't know what reminded me of this. Well, it's the paperclip that reminded me of it. I'm dating myself. Do you remember it was like in the late 90s, early 2000s, Microsoft had the little assistant on the page and it was called Clippy? We're going to bring back Clippy. Everybody needs Clippy in their test kit.
I am telling you, I love that. That's a thing. By the way, when I traveled and did troubleshooting, I brought the paper clips with me, and I would pull them out of my pocket, and they'd look at me like I was crazy. And I could take the paper clip and touch them to the tips of the conductivity sensor, and the reading should skyrocket. I could touch them for the flow switch and see if the flow switch is operating, and I could touch them for the water meter and see if it's operating. Done.
Paperclip, everybody's favorite troubleshooting tool.
Paperclip. Do not use the paperclip on 120 volts.
Only once. You only do it once.
Yeah, exactly. Light you up just a little bit. So the next signal we talk about in our industry a lot, because again, PTSA, drum levels, is the 4 to 20. It's a little different beast because to measure current, it has to flow through the multimeter. So in that case, I'm going to actually break one of the connections for the signal coming from the 4 to 20 milliamp. So I have a signal either going out to the probe or coming back from the probe, one of the two. I break that and I clip onto it with my red lead, and I take my black lead and I touch it where it was touching the controller, and I set my scale for milliamps because the current, that 4 to 20 milliamp current, has to flow through my multimeter to be able to measure it. So it'll be DC milliamp setting, and I run it through. Now, with it set to DC milliamps on your multimeter, if you now forget to take it off of that and actually touch something with a voltage, you'll short out that thing you're touching, and you'll also pop the little microfuse that's in your meter. So it's one of those things that when you're messing with 4 to 20 milliamp signals where you're bringing them through the multimeter, you want to make sure that the second you're done checking that signal, you change your setting either to volts AC or volts DC. That's always the safest signal to stay on too, by the way, volts AC or volts DC. If you stay on resistance, we're actually putting a voltage out and you'll wear your battery down faster, even just sitting there. But if you're just in volts or off, but if you're in volts, AC or DC, you're not putting out any signal. You're actually waiting to measure a signal. So a little different draw.
That's a great tip. I've also heard you explain, what is 4 to 20? Why do we use 4 to 20? What is the controller doing with it? So do you mind doing that for the Scale It Up Nation?
Not a problem. So 4 to 20 milliamp signals let us use kind of a universal proportional signal where the difference between that signal's load number 4 and 20 number 20 milliamps is proportional to whatever device it's actually transmitting from. In the case of a pH sensor, 0 pH would equal 4 milliamps, 20 or 14 pH would equal 20 milliamps. Therefore, 7 pH would equal 12 milliamps. Halfway between the 4 milliamps and the 20 milliamps, the 16 milliamp scale is 12. So why 4 and 20? Why not 0 and 20? Well, in the days of yore, and actually to this day, the device that's actually out there that's processing the 20 milliamp, the first 4 milliamps was used to power all the electronics in that device. That was the load of the device. As an example, your flow line drum level. The first 4 milliamps of the signal is actually powering the drum level. It's beaming its ultrasonics. It's all doing that based with 4 milliamps, which is a very tiny current. It's doing all that functionality. And then what it does, since it's using that first 4 milliamps for power, is it proportionalizes the current draw between the 4 and the 20 that equals what it's reading. So it's in control of that. So it's varying the value between 4, which is just the minimum needed to power it, and 20, which would be the maximum it could scale out at. So with that, 0% full could be 4 milliamps. 100% full of chemical in the barrel could be 20 milliamps, or you could invert that. So that's the beauty of the 4 to 20. It's proportional too. With PTSA, which is a little different. PTSA is a powered sensor where the 4 to 20 milliamp is the signal, but we still have to provide, as example, the Pixis sensor, or even the Turner sensor. We have to give it 24 volts to power that sensor because the electronics are much more complex and they draw significantly more than 4 milliamps. So we give it its own power, its own 24 volt powers, and it gives us back the 4 to 20 milliamps in proportionality to it, with 4 being 0, 12 milliamps being 100 ppb, 20 milliamps typically being 200 ppb. See, it's a 4 to 20 milliamp signal, but I can use it for any reading and proportionalize it. And within my controller, I have to set that scale correctly for the 4 and the 20 milliamps. Using the multimeter to check the signal on the way back, that's the easiest way to do any troubleshooting.
Tom, you've been doing this for a while. I'm sure you've got some stories. So why don't we start out? What are your top 5 troubleshooting calls you've received?
Well, the one I like to relate actually didn't happen to me. It happened to my cohort, Joe Zasky, when I was back at Lakewood. He'd been troubleshooting with a water treater on one of our old 1575 controllers, which they're all still out there, by the way. Those things are bulletproof. And what it was every time the controller through a relay, the controller would blank out and then come back on. And the guy swore that the controller was bad. And Joel said, look, there's a switch in there where it's set to 115 volts or 230 volts. And it's probably set to 230. So it's only running on half the voltage it should anyways, out of the little transformer that's inside the controller. So when the relay calls, it's pulling too much juice, it's resetting. So just make sure that that's set to 230. The guy swears to God it is. He just knows it is. He's not buying it. You need to come out and fix my controller. You need to come out and fix my controller. So Joel very politely said, look, I'll make you a deal. I'll fly out and look at the controller. If it's something else that's messed up, trips on us. If it's the controller, but if it's something we've already kind of walked through you with, trips on you. And the guy goes, you betcha. So Joel flies out, walks into the facility, the customer facility, again with the water treater. They walk up the controller, he flips open the lid and he takes the switch and he flips it from 230 to 115. And again, the guy had been told 17 times that that's what he needed to do, and activated all the relays and it stopped. It didn't blank out. It worked. And the guy just looks at him horrified and Joel goes, I think that's like $1,500, buddy. Yeah. So kind of the lead of that is we are really trying to help you guys solve this. And so when we're doing this phone support, we're asking you to do things. Don't give us the answer you think we want to hear. Don't jump ahead while we're stepping through things with you. I know you start seeing the light and you go, oh, no, I know what to do next. Don't. So let us attack it in the way that we usually attack it. And that way we will catch all the little bugaboos and resolve it to be either inside the controller, a setup issue, or outside the controller. And the cool part about it is with people like myself and Paul Peacock, who happens to work at Aqua Phoenix as well, we are really good at the out-of-the-box troubleshooting. And by out-of-the-box, I mean out of the controller troubleshooting. It's not the controller and it's not the sensors. These are the things in your system that are going to make you have a problem, that can give you these indications like it's a controller problem, but it's actually not. Which actually takes me into my second favorite. Went to a site because every time they turn a relay on, the controller would shut off and it would pop a breaker, but it wouldn't pop the fuse, which is weird. So I got to the site and I was like, all right, I got to see it to believe it, guys. Show me. And this site was just crazy outside, conduit everywhere. The site had 17 modifications to it, just in general plumbing and electronics. So they just done their thing. It is an old plant. And I'm standing there and sure as heck, the solenoid comes on and the breaker pops. I'm like, that's weird. So I go into it and I'm like playing with it. And I'm like, man, everything is right. The usual, the switch thing, all that. And I said, last chance. I took my multimeter. Hey, a multimeter. Yes, a multimeter. And I put my red on the hot and my black on the neutral, and I measured the voltage. And then I left my black on the neutral and took my red and took it to ground, and I measured 120 volts. And I went, that's not good. Off a neutral. Neutral should be basically the same as ground. And so I went to the plug. I pulled my controller out because I thought, well, maybe something goofed in the wiring, which would be weird. And I did the same thing, hot to ground, hot to neutral, and it had the same thing. And I looked at the guy and said, that outlet's miswired. And he goes, no way, that outlet's been here 35 years. And the usual, I said, it's miswired. I said, leave the breaker off, give me a screwdriver. So opened it up, pulled it out, and sure as heck, the hot was wired to the neutral, and the neutral was wired to the hot. And basically, we were shorting to ground every time we turned the controller on and we flicked the solenoid valve on. We were shorting to ground. So I said, hey, you rewire that, and I bet it works. And it did.
Imagine that. 35 years, never had that problem.
No, it's got to be what you've got going on. Most of the other troubleshooting stuff is typically setup stuff. Things like the plumbing is incorrect. We recently had one where we happened to see that chlorine sensors and so forth have to be run with very low flow through them. And someone had replumbed the plumbing so that they kind of use the rotometer that happened to be on the chlorine sensor for the entire panel. And so, we got the chlorine sensor is bad, we think. And after we kind of looked at the picture, we said, no, the plumbing's wrong. You've destroyed the chlorine sensor by putting too much flow across it, too much pressure across it. So that's just kind of one of those things when you've got to step back for a second and say, hey, what was the manufacturer's intent with this? And then what was the OEM, the panel builder, whoever the people had put it together, what was their intent? And don't try to outthink them. And don't let an electrician come and say, I've done it this way for 20 years. Or there's old Navy guys, they got their own way of doing things, and that's great for them.
God bless them.
God bless them. Boiler plumbing, another one. So you just got to say, look, this has got to be this way. And I know you think it's not, but it's got to be this way. And trust in the manufacturer that you're dealing with, whether it's Prominent or Advantage or Walchem or Lakewood or Pulsapete or whoever the case may be. When you're talking to them, they're trying to walk you through it. Trust in them first about how to set it up. And we'll debate I don't have a problem debating the electrician for a few minutes and kind of explaining what we're trying to accomplish, right? And get the thing set up right and wired correctly.
I love that you say it's the mindset, because so many people get bad customer service or bad technical support phone calls. They immediately think that this is what this phone call is going to be.
Yeah.
And you guys are of a different breed. You know just this control. Well, you know more things than that, but specifically this controller, and you want it to work as badly as they do.
Absolutely. It's self-serving. We want to keep our warranty costs down. We want to keep our customers happy. It's all the things around making sure that it does what it's supposed to in the field. So why would I try to BS my way through that? I want to solve the problem. And most of the time, it seems convenient. I need a new controller. Just send me a new controller. Okay. If I did it, though, what's going to happen is you're going to install that new controller. You're going to think you solved the problem. And a week later, you're going to have the same exact problem. And then you're going to call me and go, you sold me another bad controller. And I'm going to go, no. So I actually had in my younger days at Lakewood, I had a guy call me and say, hey, I want to buy one of your Model 2000, which at the time was the cat's meow controllers. And I'm like, great. And he starts talking and we're going over the features and what sensors. And I said, oh, great. And he goes, yeah, I'm going to replace it because I've had 3 other controllers in here and they don't work on this system. I go, whoa, no, you're not. And he goes, well, what? I go, look, as much as I disliked my competitors at the time, there's no way that all 3 competitors with 3 different design philosophies, 3 different system setups, all had the same problem on the same system. It's not possible. And I'm not going to give you mine just to have the same system problem. So I said, who do you have in there now? And I think he had a Pulsatron, the old 9000. Maybe it was, I think that's what it was. And I said, all right, what's it doing? So we went through it and I troubleshot it just like I would troubleshot one of ours. I walked him through the steps. It was just a screwed up sensor. He had it wired incorrectly. And by the time we got all that done, and again, he'd been duplicating this the whole time. The other thing he had going on, which was driving him nuts, he had a massive amount of aeration in the water because he had 75 bends, a recirculation pump that was cavitating. And we were able to prove that using troubleshooting steps by putting the sensor in a static solution and all that, the water motion was the problem. He had to solve that first. No matter whose controller he was going to put in there, he had to solve that first. And hung up. I didn't sell the controller, but I'm kind of okay not selling that controller.
Right. Tom, I want to thank you because you actually put into the Lakewood programming many, many moons ago an equation that I came up with. And I thought for sure when you did it with Lakewood, all the other manufacturers were going to follow suit. But Nation, I came up with a calculation to figure out exactly what your bleed set point needs to be. And Tom was in one of my math classes where I went over that. And he goes, I can duplicate that. I can put that as one of the settings in bleed. And you did that and you named it the Blackmore setting.
Yeah, exactly. It was your pre-bleed before a biocide feed. And the idea of it was, because we all know this, if you were, let's say you had a high conductivity and you were just near your set point and you didn't do a pre-bleed, but now you lock the tower out for your bug juice and then the lockout time for circulation, if the tower is under load, you're going to actually increase your conductivity significantly. So the first thing that's going to happen when you come out of your biocide cycle is you're going to blow down like crazy for hours at a time. And you'd actually give a calculation where you took the volume of water in the cooling tower, desired conductivity set point, all these other standard kind of things. And you could formulate out the time you should run and the pre-bleed set point you should run for your biocide, pre-biocide feed, so that by the end of the feed and the lockout time, you're almost right back on normal set point. So yeah, we called that the Blackmore method. It was a little screen off to the side. All they had to do was enter some information about their system and it spit out that number. And that's the number you should enter in your biocide setup. Yep. And I can't believe other people don't use it. I thought it was genius.
I've given it to the entire world. It's out there for them. I'll make sure to put that on the show notes page as well. By the way, Nation, it is on episode 3 if you want to go back and look at that. But we'll make sure to have that as well. Tom, it's amazing all the things that are now coming out into our industry, and it's really going to change how we do our jobs. What should we be expecting for the controller of tomorrow?
So we've kind of gotten some cool stuff now. A lot of manufacturers have the touchscreen. All the manufacturers make a NEMA, which is weatherproof enclosure, which is all become standard fare. That wasn't, by the way, that wasn't the way it was in the beginning. Like I said, I've been doing this since 1994, so a long time. And things have changed and evolved. The programming capability, the interaction, where you can have what Walkim calls a virtual input, and other people are doing as well, where you can tie two system signal inputs together in a unique way, have them operate another theoretical relay in a specific way that then makes a physical relay react to it. So you can do chain of events, almost PLC, program logic controller capability as a standard format. And that's just cool as heck. One of my latest things that I'm on is, of course, active corrosion. Active corrosion monitoring has been around forever, right? It's always been an expensive proposition and a little fiddly. I will point out that in the industry right now, if you're doing coupons, which a lot of people do, right? It's a good idea, coupons, and you're looking at the actual mills per year and hitting on the coupon, it's a false sense of security, in my opinion, because how often do you change those out?
90 days plus.
90 days. So I look at my 90-day, I send it to the lab, and they say, you've got more mills than you had in the previous set. And that's good information. Let me ask you this. When did the excursion happen that drove that higher?
Somewhere along those 90 days.
Yeah, somewhere. That's not a really good exact way to go maybe troubleshoot that. Sometime in the last 90 days, something happened. With active corrosion measurement, first of all, you're going to change them out once a year, but you put the tips in of the varying metals, the mild steel, copper, stainless steel, aluminum, brass, whatever you got going on in your system. You actively measure it. And the cool part about it, with especially the data log capability of these controllers now, is that when your mills per year, your pitting take off, at any given point in time, you see the bump and you have what do you have? You have a time and a date. Time and a date. When it happened. And you can go back and say, hey, did I overfeed bleach? For some reason, I didn't overfeed bleach. What the heck happened on this? And you can actually talk to your customer. Did anything happen on this date and time that something was introduced to cause this excursion? See, now you have an actionable item that can be resolved. And if it occurs on a regular pattern, you can say it's process related. So let's figure out what's in the processes occurring at these times that's causing me to have corrosion issues, right? And you can also show that it's your empirical evidence that you've been taking care of the system. So let's say you have a really bad last coupon set, and then the rest of them are really good. Your customer remembers that bad one, but you can now go back and go, look, everything else has been fine on that. Here's my charts. Here's all the declination on my charts. Everything's smooth. The excursion we've identified. I am taking care of your system, and I'm actively monitoring it. I've set alarms when it goes up too high at too fast a rate. It sends me an email. I can see into the controller and see what's going on. And if I'm really smart, I actually have things like drum level monitoring and so forth, so I can see if the barrel got empty. There's this entire group of technologies that let you respond and respond accurately to when events occur, rather than guessing what might have occurred between your last service visits. Right? In the old days, you walked up to the controller, you looked at it, things were running fine. You had no idea what happened in the last 30 days. And you didn't know when it happened, to what magnitude it happened. All you know is today is fine. And that's what the controller is doing for you. So I'm adamant about that and remote communications. If you're not using remote communications, why not? I have the reverse thinking about when remote communications should be applied. Should it be applied at your really conscientious, high-end, he's your biggest account, do you need remote communications? Sure you do. But those guys are usually on it all the time anyways. They're monitoring that system. That system is so important to them, it can't go down. So they're on it. Where should you absolutely have remote communications? Your lowest dollar, lowest return account needs remote communications. Because if your high dollar, high volume account calls you, an extra visit doesn't kill you. If that low dollar guy calls you, and now you're going to, ruin your day, right? You had a plan for that day. You're now going to drive 2.5 hours out of your way to take care of this one account you don't make any money on anyways, and have to mess with something. But if you had remote communications, you would instead zing into the controller and verify what he's got going on. I use kind of the same example every time. Bob calls you up, and Bob says, hey, we marked the inhibitor barrel and it ain't going down and there's something wrong and you need to get out here. And so you go, okay, now without remote communications, you go, crap, all right, so I was going to go here today and there. And maybe if I get him on the way back and he's pretty excited, I'll drive out there this time. But you had to put something else off because you've already got a full day. But remote communications, I zoom into the controller. I'm looking at the controller live. And I go, Bob, I'm going to turn on the blowdown valve. And I turn on the blowdown valve. And sure as heck, a few minutes later, the conductivity starts going down, which means the water meter should have kicked, which means I would have fed some inhibitor. But the inhibitor relay never comes on. All right, Bob, I'm going to turn the inhibitor relay on. Did the pump come on? Yeah, it did. Okay, that all setup is good. But my water meter is not accumulating. Okay, Bob, here's what I'm going to do. I'm going to change how I'm feeding the inhibitor to based on time or feed after bleed, some sort of temporary thing. The programming's already in there, guys. You just use it. To this temporary thing, it's probably your water meter. So what I'm going to do is I'm going to come out there with another 3/4 inch water meter on my regularly scheduled visit. And I'm going to go ahead and turn this manually on for a few minutes to get your inhibitor back up to where it should be. Are you taking care of Bob? And Bob's taking care of. So is that worth $12 a month, which is pretty much what your remote communications cost on a regular basis? If I can stop you from making a single extra trip in a month to a low dollar account, is it worth having remote communications out there? So why wouldn't you have it on that account specifically? And I know, well, Bob doesn't want to pay for it. Well, I know Bob doesn't want to pay for it, but you're going to.
It's a great point.
If you don't have something. So, yeah, remote communications are where it's at. And that, and of course, all the online data accumulation, cloud accumulation of like service reports and all the stuff that the controllers can now feed into the system. So you can make honest to God analysis of what you want to do with your controllers and what you want to do with each of your accounts. I like Advantage has this and Walchem has, I'll use the Walchem example, the Fluent. So Fluent is a dashboard in Walchem for your Walchem controllers where you zing into it. You have a company person that manages your overall controller scheme, but they hand the ones for your accounts to you. You zing into it in the morning, and right up front on the dashboard is any controller that's an alarm. You can click on the main facilities you're going to deal with that day, get a lay of the land, and you know what to bring with you. Do that at 7 o'clock in the morning or 5 o'clock in the morning while you're having a cup of coffee. A lay of the land. What am I doing today? Where am I going today? What do I need to take with me today? That is so much better than getting there and finding out you needed something. And the tools, because the manufacturers have gotten really good at this, the tools are so smart and so helpful and so broad to get you through that day if you're not using remote communications and the tools given to you by the manufacturer to optimize your time, you're burning money. And if you're the owner of the company, your techs are burning money. Your salespeople are burning money because they're having to do things in an afterthought instead of pre-planning and be able to plan and execute that quick. So,
Tom, one of my favorite things I used to look forward to, it was like you were Oprah. It was one of your favorite things that you gave to me and many of us at the AWT conferences, was the troubleshooting kit that you used to build. And I used to look forward to every year because I used to get a new one and I needed to replenish by then. I know that's something of yesteryear, but my question is, what should every water treater have with them to troubleshoot?
again, it's the water meter, it's the paper clip, and if you can stretch the dollars, get the probe simulators. Either buy them from the manufacturer like Advantage, or you can kind of create some. I can actually give you some pointers. Maybe we can link to them. Give me a chance to kind of put together a few things. You can cobble together your own little setup. And that's the sort of stuff that lets you, and which, by the way, that kit included as well. That kit we used to give from Lakewood, we had a wire brush in there just for probe cleaning. We had a couple of little clip-on fixed value simulators for the sensors that you could run, including the pH. We had a flow switch set up. And the reason we did it for Lakewood specifically is people would loosen the lock ring to mess with the flow switch, and they'd set the full site back in, but they wouldn't lock the lock ring. So the second they hit it with water, that site, and the little float has a magnetic deal in it, so it would get stuck on a steel beam at the roof, and you just stare at it. I would have guys they go, "Hey, I got to order a float," and I go, "You lost it?" He goes, "Now I'm looking at it. It's about 60 feet above my head." Okay, sorry. So yeah, so they would have one of those, and you can put together your own version of a care kit. So for an Advantage controller or a wall cam that has pieces that aren't common, gaskets for sensors are an example. When you buy and I don't care who the manufacturer is, you buy a pH sensor, it comes capped in such a way that the glass is some sort of fluid. That thing, that little bottle, that little cap, save them. Everybody, your first inclination, you either leave it or you toss it. You better have 10 of them, and I don't care where you get them, in your bag. Because during a layup or during troubleshooting, you're going to need to keep that sensor wet. And how are you going to do it if you don't have that little bottle to do it? All right. And the other thing I suggest everybody look into is if there is a plug, which would be like almost a little square or a little round disc rather, that you can substitute in the T for your sensor. So if a sensor goes bad, example, a Pixa sensor, which is a relatively expensive sensor, if it goes bad and you need to return it to the factory for evaluation, you're either replacing it with another Pixa sensor, a new one, that's probably going to be out of pocket initially, or you can go ahead and use the little, we happen to make one, a little plug, you plug that T off and you send the sensor back. Now, yes, you don't have PTSA control temporarily, but at least you're running because you plugged the sensor. So you should have a little adapters, and everybody sells them and everybody makes one, and you can actually make your own if you got a jigsaw in 20 minutes probably of a T block that allows you to actually move things around and pull things out of the system and put those little T blocks in. Handy as heck.
Tom, I'm willing to bet that most of your troubleshooting calls around boiler controllers is probably a plumbing issue.
You are 100% correct. So, first of all, nobody cleans their boiler sensors like they should, because I get they're a pain in the rear to pull. I mean, they're threaded in there, they're doped in there, the system's operating. There's a million reasons not to clean the sensor. Tom Tinney advises that you clean them at least once a season, and more if you possibly can, and doing the same method that I would do on a cooling tower. Now, the wall cam, I have to differentiate that. Wall cam has that one that's got more of a center pin in it, an outer body. So you skip the brushy part and you just go for a longer soak in the acid or the CLR. I don't care what you got to chew that stuff off of there to get it off of there. So yeah, clean your sensor often enough. And when replacing the boiler sensor, the old Navy guys, their philosophy is whenever you have an MPT thread, you screw it in until it squeaks. You run it until it squeaks and you hear a little grind. That means it's tight. The problem with that is with an MPT, which is actually an angled thread going into an angled pipe, it gets more and more compressed the further you screw it in. And in the case of our sensors, what you're compressing is a very thin stainless steel outer shell with threads on it. And then everything that we put in the guts of that sensor, O-rings, the electronics, the mechanical fit up between the sensor and the wires, that's all getting squished and distended and bent out of shape the harder you tighten it down, to the point that you'll actually create a leak. And then you've just ruined that sensor. So Tom Tinney's law on boiler sensors is you run them in by hand, tighten them up by hand as much as you can, put a little grunt on it, and then you go 1/2 to 3/4 of a turn more with a wrench, and you're done. And if it leaks, change the T or get a new sensor because you've damaged the threads. Do not keep cranking it down to make it stop leaking because you're squishing the guts of my sensor. So let's suppose you've listened to me and it isn't the sensor. Most of the time, your boiler, when your boiler is not able to be, your boiler sensor is not able to be calibrated correctly, or you're inconsistently reading the boiler, or it reads 0 all the time, and what the heck's going on? It's because the plumbing is set up incorrectly. So let's talk about the plumbing coming out of a boiler. We're typically on a skimmer line. We come out of the skimmer line. We should drop down. I prefer Lakewood's method for putting sensors in. Once people get that installation done correctly, and you can get an old Lakewood 1575 manual if you want and see how it's done. It's more of a out of the skimmer line, drop all the way down to near the ground, make a right turn. At that right turn is a cross where you put the sensor in horizontally. Afterwards, you do the motorized ball valve, and then you do the throttling of some kind, whether it's an orifice union or an actual dial-in throttling valve. That's for a sample cycle or sample hold, whichever one. That's my favorite way to do the plumbing. On the way from the skimmer line down to the sensor, all that plumbing has to be the same size or going smaller. So I can go from 1 inch to 3/4 of an inch to 1/2 inch all the way down to my sensor. That's good. All right. And then we 1/2 inch after that all the way out. I cannot go 1 inch, 2 inch, or 1 inch, 1.5 inch, and then down to 3/4. That 1 inch to 1.5 inch is an expansion chamber. An expansion chamber is a reduction in pressure, which allows the boiler water to foam up or to have steam flash, typically foam up, that creates a foam that gets pushed across your sensor tip. And what that foam doesn't read necessarily 0, because the foam itself is conductive within its bubbles, and the bubbles interconnect, so you get a tiny reading of the resistance or the conductance across the foam, not like it's a solid column of water. So it's like, hey, it reads like 1/3 the value it should, but it's reading something. That's foam. Now, because you've cleaned your sensor, we've eliminated that as a possibility. That's foam. If I gave it a solid column of water between the tips, I would get an actual valid reading. So it's either foaming because of expansion, because of the piping was undersized, or oversized, undersized, oversized, or your throttling mechanism, which is providing back pressure. And that's what we're trying to do. We need the boiler water at pressure and temp to move through the skimmer line. Well, I have to provide a release for that. If the release hole is too big, then because we're going to atmospheric typically, the line depressurizes, instantly forms foam. If it depressurizes too much, instantly forms steam. I can't read either of those with my probe tip. So the throttling has to be correct. If I'm using an orifice union, typically 1/8 of an inch hole or smaller, or if I'm using like a globe or a needle valve, 1/2 a turn, maybe 3/4. If you've got that valve spun way open, you're steam flashing or burbling, one of the two. So you're creating your own problem. So plumb it correctly, which is, again, down the right side, horizontally into your motorized ball valve and your globe valve. Probe sits at that horizontal cross section, right where it makes the right turn and across. The reason I say across is because you want a bottom plug on the bottom of that cross so you can actually clean out gunkies occasionally, and then run it across your motorized ball valve and then your throttling valve. People sometimes put them backwards. Again, your choice. I just over time have found that with the throttling valve ahead of the motorized ball valve is more of a chopping, steamy thing smacking into the motorized ball valve versus letting it release slowly after the motorized ball valve opens and closes. So I prefer the motorized ball valve than the throttling valve, which is actually kind of brings me to a weird thing. I get asked all the time, because the skimmer line is 1 inch, can I get a 1 inch motorized ball valve? And you never need more than a 1/2 inch motorized ball valve on anything. You just don't. Because give it a second of thought. I come into 1 inch, I go down to 3/4 inch for my T where my sensor is. That's everybody's T. That's everybody's sensor. After that, I could neck it down to 1/2 an inch, run it into a motorized ball valve and a 1/2 inch throttling valve, because the hole that I'm putting it through on the throttling valve where the orifice union is how big? 1/8 of an inch. So why do I need a 1 inch pipe? So why would I buy a really expensive 1-inch valve or a more expensive 3/4 inch valve when a 1/2 inch pipe, 1/2 inch plumbing after the boiler sensor? Because again, we're going bigger to smaller, right? That's more compression through an orifice union that's 1/8 of an inch. So, buy what you want, but if you apply a little bit of logic to it, 1/2 inch is the way to go. Get the plumbing right. And I have had so many guys that said, I'd say, hey, did you do the plumbing like the sheet I sent you? They go, yep, it looks exactly like that. And I go, oh, cool. I said, could you send me some pictures? Like, take a picture out of the skimmer, like just kind of follow the system through. And I get these pictures and I go, what is that? And I go, so what did you do here? He goes, oh, well, that's not exactly like the drawing, but it does the same thing because it sort of looks like, I'm like, dude, you can't do it that way. You can't apply that logic. It needs to look like the drawing. And amazingly enough, when they convince the site, again, who doesn't want to replumb, to do it correctly, all of their variances and the randomness and the things that they were dealing with start going away. And now we can talk about tuning the boiler, getting the system lined out, saving that energy and saving that chemistry that we wanted to in the first place. So, yep, boiler plumbing is the bane of my existence, and it has been since the beginning. But now that people are starting to listen, maybe a little less.
You're getting the message out there.
Exactly.
Tom, as far as the boiler controller of the future, what are some things that we can expect there?
So I think that the boiler controller, the evolution of the boiler controller, which is kind of cool, again, is as a controller that can do multiple boilers. So we've already got that. And able to also use the new sensors that are coming along. So if I have a boiler controlling multiple boilers, but they're coming off of a DA tank, the chemical analysis of the DA tank is a big deal. And it used to be kind of pricey, but it's come down significantly. So now we can do fluorescein, dissolved oxygen actively out of a DA tank. Sometimes we luck out and there's a way to return it to the DA tank. But most of the time, it's a very small sample cooled, doing conductivity, pH, ORP for your oxygen scavenger or dissolved oxygen, fluorescein. Pyxis has a really cool sulfate sensor now. So you can look at your scavenger that way. And we can look at all that chemistry and get it completely balanced in the DA, regardless of the operation of the boilers. Right now, it's kind of like, hey, the boiler's making up some water, so I'm going to introduce some chemistry, and I hope it kind of levels out in the DA. Sometimes I can take into account the condensate return. I don't really know what's going on in the tank, but I hope I'm getting it close. Well, we can end that by taking samples continually out of the DA tank, balance the chemistry, and when it comes to the boiler, it's doing what it's supposed to do right out of the gate, which actually kind of brings me around to the fluorescein sensors. Some guys are taking the fluorescein off of a sample cooler, again, due to the temperature rating, and they're kind of measuring, they're pulling it off the blowdown and saying, looking at the fluorescein level inside the boiler, and then trying to control it based on that. But if you think about it, you're 45 minutes behind because your sample was an hour ago, an accumulation due to loading. So how are you going to adjust the chemistry feed into your boiler and get it right? You should be taking the sample right out of the DA. You should be taking the DA sample and controlling off of it right off the bat, and then sample drain. Or you can actually, we use a little Grundfos pump sometimes and run it right back into the DA. You got to watch your oxygen scavenger level. But by doing that and having it balanced that way and monitored that way, you can also look for excursions. You can alter your control scheme. And again, with remote communications, you're pulling that entire data log. And when you crack that boiler open, it should look a particular way, right? Because you've done everything you should be doing. So I think that's where the boiler of the future. Now, we've had manufacturers talk about, and I think they've got it out now, a little higher temperature toroidal sensor, which would alleviate some of that whole cleaning thing, but it doesn't alleviate crappy plumbing. So that's kind of where boilers, I think, are going at. And then with any of these, you can take advantage of all of the drum level monitoring too. I think drum level monitoring is kind of an interesting thing that some people are doing it. Some people are demanding it. If you don't know the levels of your inventory, how are you making decisions about delivery? And from a company perspective, if I know where all the levels of all my chemistries are in all the facilities my guys take care of, I can then properly route the redistribution of chemicals from my facility on a very coherent method. Instead of zigging out and zigging back in one at a time, kind of targeted, I can have my driver make a good route, and I'm saving on fuel and I'm saving on hassle. And the other thing is, sometimes I know where some chemistry is that isn't being used, right? And I temporarily have to move it somewhere else. to take care of something. If I've got a plant that's got multiple chemical depots in it, you should have drum levels on all that stuff. And again, remotely monitor, bring it into the controller, bring it into a dashboard. I don't care where you bring it, but be able to look at it and make good value decisions about how you're going to take care of those accounts. Use and abuse the technology. That's kind of my message overall. Use and abuse the controller technologies. These manufacturers have put a lot of time and features in that people have asked for over the years. Just use it to the max. And a lot of the accessory prices to drive those technologies have come way down, and they're mature technologies now. When the ultrasonic drum levels first came out, they were kind of dicey, and we were a little bit abusive to them, and boy, they sure were pricey. And now they're pretty freaking economical. So,
Tom, I want to thank you for coming on the podcast again. The knowledge that you've accumulated over your career, you've just shared a little bit with us today, but I have no doubt the Scaling Up Nation is better for listening to these 2 episodes. So thank you for sharing that knowledge, but I'm not quite done with you yet. We have some lightning round questions.
okay.
Now, I'm curious. I don't think we had lightning round questions in the very beginning.
I don't think we did. I think we were just happy to kind of get through and stay on subject, man.
I think that was it. So I normally ask round 2 lightning round questions of returning guests, but I never asked round 1. So that's where we're going.
Cool.
My very first lightning round question for you is, if you could go back in time and talk to yourself on your very first day as a controller technician, what advice would you give yourself?
So I think that it was something I actually learned over time, but I wish I'd known it. It took me a couple of years to evolve the thought, which was you got to walk through problems in logical steps, get your customer to buy in, get them to buy into what you're doing, and just they're excited. They're having a bad day. They're at the cooling tower. They're far from home. They want to get out of there. I get all of that. But walk them through each problem in a logical step so that they see what you're doing and why. Sometimes to this day, I got to stop and do that and explain to them why I'm doing it. I've done it so many times. I know what the problem is. It's this, and this. So just go do this and this. No, I got to stop and go, look, this and this plus this is why we're getting that. Do you see that? Okay, cool. Let's go to this next thing. So walking people through and doing logical steps and not skipping anything to arrive at it. Don't jump ahead. I catch myself wanting to jump ahead. Don't jump ahead. And I think that was a hard lesson learned with a few, hey, I can't solve this right now. Or, boy, now I've just walked us into a corner. What do I do? Everything should be done that way for all the controller manufacturers or anybody messing with the electronic system. You just got to be logical. Think about the next step. And if nothing else, you could write it down and to achieve that kind of that 90, 100% success rate with it.
What are the last few books that you've read?
So I write sci-fi books. So I'm always reading sci-fi books. So my latest is I'm on a backyard starship. A buddy of mine, Terry Maggart, and another guy named Jay and Cheney. It's called Path of Tyrants is the latest one. Backyard starship. A guy comes home to his Iowa phone after his grandfather's passed away. And there's a mechanical bird sitting on his table going, hey, by the way, do you know that you should be a cop in outer space? And he goes, what are you talking about? So the backyard starship is the police vehicle. And he goes out into the universe, even though he's an Iowa farm boy, and protects the universe from bad guys.
So was Kirk.
Exactly. Same thing, right? Yeah, there you go. It was Kirk. So that's the one. And then, Tower of Silence by Larry Correia. He's one of my favorite authors, and he's got a fantasy series about Ashok the Destroyer, which is an entire series based in Indian lore, Indian like subcontinent of India. They're the only surviving people on this world way in the future. And it's all a warrior cast, and it's crazy good. And the main character is Ashok, a man born with no fear. So he is the ultimate warrior, but also kind of the protagonist through the entire series of books. And I'm on his 4th book now, which is Tower of Silence. First one is Sons of the Black Sword. And it's a phenomenal series. I just eat these things up. And then the last one I read before that, which wasn't sci-fi or fantasy, amazing enough, is called Eat That Frog by Brian Tracy.
I've read that book.
That's an awesome book, right? Because I am a professional procrastinator. So
why do it today? There's always tomorrow.
Exactly. Or, I got this other thing going on, and I'm always reprioritizing and just kind of listening through that, doing my self butt kicking because I'm listening to it going, yeah, you're right. It's the old kind of the same thing about, how do you eat an elephant a piece at a time? He just kind of cooks it down in a different way. But it's a pretty good book. I enjoyed it.
Now, you mentioned your books. Tell the Scaling Up Nation a bit about those.
So I used to write for a biker magazine. I was the editor of a biker magazine called Quick Throttle. which was phenomenal. And everybody from the magazine and fans and so forth would say, hey, you should write a book. And so, because I would do these stories about events and stuff, and they're like, you should write a book. And so finally, Paul Peacock was like, you should write a book. Yeah, I used to work with and still do. I said, all right. So I said, well, I want to write this book. So I wrote a sci-fi book. And everybody's like, wait a minute, where's the biker book? And I'm like, no, this is what the book. And it was called Threads. It's a space opera book. Actually, Bruce Ketrick, I love Bruce, called me because he bought a copy at the show. It was a text message. And he used a bad word and told me to, it myself. And I was like going, oh my God, I had no idea how to connect the two. Why is Bruce mad at me? And it's like, what's going on, Bruce? And he says, hey, I just got halfway through your book. And he goes, and I realized everything I thought was going on isn't what's going on. So then I had to go back and read the first part of the book, make sure you hadn't cheated to get me there, and you didn't. And I go, oh, cool. He goes, no, I had to read half the book again. I go, sorry. And then the second book I wrote was with my son. I hadn't met him or found out about him until he was 18. We eventually connected. I found out we had the same interests. He is me. That's the weird part. He was raised in Australia, completely different societal structure and all that other good stuff. And he's me, 100%. We like the same things. We have the same kind of smart alecky attitude. My entertaining part of that is I thought, his mom had to raise me, and that was no fun at all. So him and I with the same interests, we started corresponding, and we said, hey, it'd be cool if there was a story that did this. I saved the text messages. I saved the emails. After I published my first book, I came back to him and said, let's write this book. We'll use the royalties so that either you can come out and see me or I'll come out and see you to meet the first time physically. So we wrote the book, him from Australia, me from the United States, over about a year. And it was a finalist for a Dragon Award at DragonCon. It actually made the finalist cut, made enough royalties. Also, thanks to Larry Correia, the author I talked about, he kind of pumped it up a little bit with a post he did, made a good amount of money, and was able to fly to Australia and meet him and my new granddaughter and my daughter-in-law. So it was a very cool experience. And now people are waiting for part 2 of each of those books, plus a couple of other books that I've talked about and short stories I've done. And so, yeah.
And when can we expect those?
So did I tell you about this book I read called Eat That Frog?
Understood. Tom, there is no doubt about it that Hollywood loves controllers. In fact, if you go back to the quintessential Christmas movie, which is Die Hard, and you see where they're putting the explosives up on the roof, there is a cooling tower scene there, and there is a perfect shot of a Lakewood controller.
Model 412. My wife lost her. So she bought me the 4-disc set for Die Hard because, of course, Die Hard is the greatest Christmas movie ever made.
Of course.
So I'm watching it, and Bruce does his thing, and he runs across the scene, and I see the blue box with the 2 dials on the wall because that's where my brain's at. And I pause it, and I back it up, and I go, that's a Lakewood controller. And my wife goes, what are you talking about? And I go, that's one of our old controllers. And she says, who cares? I go, I do. So I took a picture of it, and I sent it to Lawrence Salzman, who I used to work with, who used to be a part owner in Lakewood. I said, that's a 412, isn't it? He goes, it is. So I got in the office the next day, and I looked up the Nakatomi building. What was the real name of the Nakatomi building? It was actually a Fox Studios building. I called them and said, hey, can you let me talk to somebody in maintenance? Because I saw this controller in Die Hard. You're the Die Hard building, right? And the guy's like, yeah, we're the Die Hard building. He goes, let me get you a little Chuck or whatever the guy's name was. And so he gets me a guy, and I said, hey, I'm Tom Tinney with Lakewood Instruments. I'm watching the movie. There's a controller on the roof. It's one of our Model 412s. He goes, oh, yeah. He goes, that thing was there forever. He goes, it was actually installed months before the building opened. It was there. And he goes, 2 years ago, we took it out. And I go, please tell me it's sitting in your office because I will take that controller and I will give you a new one. He goes, nah, we bend it. He goes, but it was on there from 1988 until 2012.
It did not owe anybody anything.
Nope. We saluted that soldier and moved on. But I thought that was the coolest thing now. So, yeah.
So, well, because of that, we know that Hollywood loves controllers. So they're going to hear this episode. They're going to want to make a documentary or a movie or something about your life. Who's playing Tom Tinney?
Oh, it's Brad Pitt. Come on. I mean,
I feel like I was looking at Brad Pitt this entire interview.
Exactly. So they put him in like a 100-pound fat suit and put some old guy makeup on him and maybe make him limp a little bit. And me and Brad are like simpatico. We are like right on target with each other. He wishes that he looked as good as me at my age.
Absolutely.
By the way, he's like 2 years younger than me, so no, he doesn't.
Tom, my last question. If you had the ability to talk to anybody throughout history, who would it be with and why?
I think I'm going to answer this. I think I answered it this way before. I think it's the same guy, Ben Franklin. Just such an interesting guy. The birth of the nation, his machinations in it, a world traveler, philosopher, newspaper guy. And the stuff he did, and I've read a couple of the pieces from his autobiography, and he just keeps coming up through the thread that is what we are today. All those things. He's just interesting, man. He just kind of a Renaissance man, but at the 1700s or 1800s, early 1800s, and just so interesting. I wish I could be like him. Done a lot of weird stuff. Like my career path has been a crazy career path from the time I started in the Air Force at 17 with radar tech, and then I quality assurance for aerospace, and then automotive equipment, the control systems and plastics design, and then tool shop. I've just had this kind of crazy wild ride that got me into water 1994. And I've been playing around with water ever since, but just that and Ben Franklin, I get it. I got the attention of a squirrel when it comes to new stuff. And I think probably he did.
Shiny.
Yeah, he did too, but I think he had more of a good philosophical take on the world and just kept kind of grinding at it and doing his thing. So yeah, Ben Franklin, awesome.
Tom, we're going to make sure to have your contact information on the show notes page. Once again, thank you for coming on the Scaling Up H2O podcast.
Thanks for having me back. Very cool. So glad that it's been successful. Wish you many more episodes. And, anytime you've got kind of a thought and you want to ask me something, or if we want to do this again, I'm more than happy to do it.
I love having conversations with Tom Tinney. I have known Tom Tinney forever, and we both volunteer with the Association of Water Technologies on the Education Committee. And because of that, I have learned so much with how to better troubleshoot a controller. And I've passed that on to people that work with me. He is just a master when it comes to that. And Nation, can you believe that he was one of the very first guests that I had on this very podcast, episode 3? Oh my goodness, it is so hard for me to think all the way back to April 2017 when he was on the podcast. And just so many things have happened since that time to think about how many listeners we have now and how many countries that we are in. We are rated in the top 3% of all podcasts that are presently airing. And that is a goal I didn't even know existed back in 2017. And I am so humbled that that's where we are now. And it's because of listeners like you letting other industrial water traders know that we have a podcast called Scaling Up H2O. And it's because of great guests like Tom Tinney that just shares the wealth of information that he's collected over his career and freely sharing it on the Scaling Up H2O podcast. Folks, at the end of this year, we are going to hit 400 episodes. Now, I know what you're thinking. If you listen to this show, Trace, you already have over 400 episodes. Yes, but I did a weird thing with numbering in the very beginning. So we're not going to count that. We're just going to count the numbers that we have now. Again, when you do something new, you try to reinvent the wheel. You really don't need to do that. And when it comes to numbering episodes, 1, 2, 3, 4 works fine. You don't have to put a 1.1 and a 1.2 in there. Of course, I know that now. At the time, it was a stupid thing that I did. But hey, maybe it's fun when you're looking at all the different podcast episodes that we have out there. But all that to say, we are going to hit 400 this year. It's our very last episode this year is going to be episode 400. And I just think of all the people, all the wonderful guests, all the people that help us with content in order to make it to 400, just like our friend James McDonald.
Welcome to Drop by Drop with James, the podcast segment where we wonder, explore, think about, imagine, and learn industrial water treatment, you guessed it, drop by drop, together. In today's episode, We're thinking about chlorine chemistry and the reservoir effect. Have you ever heard this phrase before? The reservoir effect? In the debate between which is a better biocide at higher pHs, chlorine or bromine, the reservoir effect is an important concept to consider. When sodium hypochlorite, chlorine gas, or even calcium hypochlorite mixes with water, the target product they produce is hypochlorous acid, or HOCl. This hypochlorous acid is subject to a dissociation which converts some of it to the hypochlorite ion, or OCl-, which is a weaker biocide than hypochlorous acid. The pH of the water has a major impact upon how much this dissociation happens. That's at the heart of the whole chlorine versus bromine debate, because the chlorine chemistry dissociates more at a lower pH than bromine does. This means more hypochlorous acid is converted to the weaker hypochlorite ion at a lower pH than hyperbromous acid is converted to the hyperbromate ion at the same pH. This concept is used to justify using bromine chemistry at higher pHs versus chlorine. But is this argument as simple as this? I propose the reservoir effect muddies the waters a bit. I just talked about how the hypochlorous acid associates to the weaker hypochlorite ion. This dissociation between the two is a very tight and fast ratio. It's an equilibrium reaction. As soon as the hypochlorous acid is consumed in the battle against unwanted microbiological activity, some of the weaker hypochlorite ion is quickly converted back to the stronger hypochlorous acid form. This is the reservoir effect because even though the hypochlorite ion is weaker, it is waiting there to turn back into the stronger hypochlorous acid very quickly when needed. Sort of like the Incredible Hulk, Bruce Banner is the mild-mannered hypochlorite ion just going about his day. But when push comes to shove, he bulks up and turns green. Although green isn't a good thing in a cooling tower, but you get the point. Now, there are certainly many other factors when comparing chlorine chemistry to other alternatives in a cooling tower system. But the reservoir effect is one that I don't think many people know about nor consider. Think about it. I'm James McDonald, and I want to encourage you to be like water by forming bonds with those around you, dissolving new knowledge, and making worthy ripples, drop by drop.
Well, thank you, James. And James, if you ever want me to do another accent for drop by drop like I did last week, or actually 2 weeks ago for Detective H2O, you let me know. I am working with my accent coach to make sure that I am ready when you need me. Nation, I love bringing this podcast to you. So thank you for listening to it. So I've got people that want to listen to it. And I hope you have a tremendous week. Until next week, take care, Scaling Up Nation.